Hello everyone, this is Dr. Evangeline Supriya working as an associate professor in the Department of H&S, SRIT Engineering College, Rotripuram, Anantapur. Welcome to the Engineering Physics Lab. Today we are going to perform the dark room experiments. The experiment we are going to perform today is determination of the wavelength of the given light source by using diffraction grating. So first of all, this is called the diffraction grating. A grating is an optical device which consists of large number of slits of equal width separated by the equal opaque spaces. Diffraction means bending of light ray around the edges of an obstacle. Now this is the apparatus. This is the light source, mercury light source, and this is the spectrometer. This entire spectrometer consists of three parts. One is collimator, this is the prism table, and this is the telescope. As you can see, this collimator is not movable, whereas both prism table and telescope are movable. Where collimator and we have two scales. One is vernier scale, which is black in color, which is attached to the prism table, and the another one is main scale, which is attached to the telescope. So before going to start the experiment, there are some preliminary adjustments we have to do for the spectrometer. One is we have to focus the telescope to the distant object. So if I focus the telescope to the distant object like this, I have to see the inverted image of that image. So the second thing is, again we have to inline the telescope with the collimator, and we have to observe the white narrow slit by adjusting the two keys. These two keys are called as rock and pinion keys. Now I am going to adjust the white narrow slit across the crosswise by adjusting the rock and pinion keys. Now I have adjusted that. Thereafter, here they said we have to find out the determination of the wavelength of the given laser source by using normal incidence method. So the steps we have on the normal incidence method, there are already we did the preliminary adjustment. One is we have to focus the telescope to the distant object. That should be inverted image. And second thing is we have to inline the telescope with the collimator, and we have to observe the white narrow slit by adjusting the two keys rock and pinion. And third thing is we have to adjust the vernier scale of zero scale of the vernier to the 0th degree of main scale 0, 0, 0, 180. And now for the normal incidence method, we have to move the telescope to the 90 degrees on the main scale. Now I am moving the telescope to the 90 degrees. Now we have to see the inverted image by adjusting the prism table. Now I am rotating the prism table. I have seen the reflected image of the slit. After this, we have to move the vernier to the 45 degrees. Now it is 90. I am moving it to 45 degrees. Yes, after moving to 45 degrees, again we have to inline the telescope with the collimator and check the white narrow slit, and then we have to see the spectrum on both left side and right side of the grating. Now I am moving to the right side. As you can see there is a formation of Vibgyor. You can see the formation of Vibgyor only through telescope, especially in the dark room. So as you can see this is the diffraction grating normal incidence method, where you can see there is a formation of spectrum on both sides of the grating, whereas in the dispersive power of the prism there is only one side formation of spectrum, but in the grating there are two formation of spectrum on both sides of the grating by using the normal incidence method. Now after formation of the spectrum, as you can see this, we have to determine the spectrometer reading. One is on the left side spectrum, another is right side spectrum. So first of all, we have to coincidence on any side. Here it is having left side spectrum. Now we have to coincidence with the violet, green, red. Of course, there are a lot of colors, but we have to coincidence with according to the table here, violet, green, red, that is considered as VA, VB. On left side it is VA and right side it is VB, and again VA, VB, both main scale reading and vernier scale reading. Here MSR means main scale reading and VSR means vernier scale reading. So already I told in my previous video, what do you mean by least count? A least count is the minimum reading any device can get is nothing but least count. As you can see here, the formula for the least count is equals to value of 1 MSD by total number of vernier scale divisions. In the spectrometer experiment, as you can see in the main scale and the vernier scale, the value of one main scale division is that is, as you can see, this 30 minutes, and total number of vernier divisions is 30 minutes. So according to the formula I have given, as you can see this, substituting all the values, we can get the least count of the spectrometer is 1 minute. 30 minute by 30 minute, 1 minute. Now, in order to find out the main scale reading, first of all, you should see there are 30 vernier scale divisions. I have coincidence with the violet, you can see here. So for the first color violet, you can see here the 0th scale of the vernier scale coincidence in the main scale reading as 342 degrees, 344 degrees, 30 minutes on the left side, which is considered as VA. On the right side, it is having the 169 degrees, 30 minutes, which is considered as VB. Likewise, we have to determine the vernier scale reading, out of which 30 vernier scale division, once division is coincidence with the main scale division, that is the vernier scale division. So the vernier scale reading should be between from 0 to 30. Likewise, we have to determine the reading for violet, green, red on the left side. Again we have to, on the right side, again we have to coincidence the spectrum on the left side. Now as you can see this, we have the formation of the spectrum on the left side too. Again, likewise in the first right side, we have to take the reading as VSR and MSR on both left side and right side. We have to do the calculations VSR into least count, and we will get the telescope reading. After getting the telescope reading, now we can see that we have the determination of wavelength. These are some calculations you have to do, and then at last we have to finally determine that lambda is equals to sin theta by small n into capital N angstroms, where n is the order of the spectrum, which is n is equals to 1, and capital N is the number of lines on grating, that is 5905.5 lines per centimeter. These values we have to substitute here, and we will get the, here we got the angle of diffraction theta. After substituting all the values, we will get the value of wavelength angstroms. So that is how we can determine the wavelength of the given laser source, which is mercury source, by using the diffraction grating. As you can see, this is a grating, using the normal incidence method with the spectrometer. Thank you.